Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? And here we have to find the value of this integral that is from 0 to 2, and we have mod of 3x minus 4, right? So here our integrand is an absolute value function, right? So let us denote the integrand by f of x. So we have f of x is equal to mod of 3x minus 4, right? Now see here our lower limit, the lower limit is 0 and the upper limit is 2, and we have to go from 0 to 2, right? So here we have 0 and here we have 2, right? Now whenever we solve any definite integral in which the absolute value function is involved, what we have to do, we should try to break the integral, right? So we'll try to find out the breaking point where we have to split the integral, right? So here in order to find out the point where we have to break the integral, what we will do, we'll solve this equation, that is 3x minus 4 is equal to 0, right? So we have the function 3x minus 4, which is a linear function inside these two vertical lines, and we'll solve this linear equation to get the breaking point, right? So we have 3x is equal to 4, so x is 4 over 3, and x is equal to 4 over 3 is greater than 1, and it lies somewhere here, right? So at this point we'll break our integral I. So now let us consider this first interval, right? So the first interval is from 0 to 4 over 3, right? And the second interval is from 4 over 3 to 2, right? So when x lies in this interval, that is from 0 to 4 over 3, then the value of 3x minus 4 is negative, right? Because see, whenever we take any value of x which lies between 0 and 4 over 3, then 3x minus 4 has the sign negative, right? For example, if we take x is equal to 1, right? So here if we take x is equal to 1, which lies in this interval, so 3x minus 4 is 3 times 1 minus 4, that is 3 minus 4, that is minus 1. So here we have a negative sign, right? And when x belongs to this interval, that is from 4 over 3 to 2, then obviously 3x minus 4 has a positive sign, right? And we can verify it by taking a particular value of x which lies between 4 over 3 and 2, right? So let us take x is equal to say 1.5, right? So when we take x is equal to 1.5, then let us see the sign of this expression, 3x minus 4. So we have 3 times 1.5 minus 4, and this is 4.5 minus 4, that is 0.5, right? So here we have positive sign, right? So now we can rewrite this function f of x as mod of 3x minus 4, and this can be written as negative of 3x minus 4 whenever x lies in this interval, right? That is from 0 to 4 over 3, and mod of 3x minus 4 has the positive sign here, 3x minus 4 whenever x lies in this interval, that is 4 over 3 to 2, right? So now we can split this integral I as a sum of two integrals, right? I1 plus I2. So I1 goes from 0 to 4 over 3, and I2 goes from 4 over 3 to 2. So now let us write I1. So I1 is from 0 to 4 by 3, and we have f of x dx, and I2 is from 4 by 3 to 2, and we have f of x dx, right? And when x lies in this interval, then f of x is equal to minus of 3x minus 4. So now this expression, that is I1, can be written as 0 to 4 by 3, and for f of x we have minus 3x minus 4 dx, and I2 is 4 by 3 to 2, and for f of x we have plus 3x minus 4 dx. Now we have two simple integrals, and this can also be written as 0 to 4 by 3 minus 3x plus 4 dx, and this integral it remains as such, 4 over 3 to 2 and 3x minus 4 dx, right? So now we can easily write these two integrals. So we have I is equal to we have minus 3 x square over 2, the integral of x is x square over 2, then we have 4x, and the limits are from 0 to 4 by 3, right? So we can take it as I1, so here we can take I1, right? Now we can substitute the limits and we'll take the difference. So we have minus 3, and here we have x is equal to 4 over 3, so this is 16 over 9 over 2 plus 4 times 4 over 3, right? And when we take 0 here, the entire expression becomes 0, right? So now we have minus 16, here we have 2 8s are, here we have 3 3s are, so we have minus 8 over 3 plus 16 over 3, right? And 16 minus 8 is 8 over 3. So the value of I1 is 8 over 3. Similarly, we can write I2. So I2 can be written as 3x square over 2 minus 4x, and the limits are from 4 by 3 to 2, right? So now let us substitute the limits. So here we have 3 times, this is 2 square over 2 minus 4 times 2, and minus here we have 3 times 4 by 3 square, so we have 16 over 9, and we have 2 minus 4 times 4 over 3, right? So this is 4 3s are 12, 12 over 2, that is 6. Here we have 8, and then here we have 2 8s are 16, this is 3 3s are 9, so we have 8 over 3 minus 16 over 3, right? And 6 minus 8 is minus 2, and here we have 8 minus 16 is minus 8 over 3, that is minus 2 plus 8 over 3, so this is minus 6 plus 8 over 3, that is 2 over 3, right? So the value of I2 is 2 over 3 and I1 is 8 over 3. Therefore the complete value of I is I1 plus I2. So I1 is 8 over 3 and I2 is 2 over 3, and we have 8 plus 2 over 3, that is 10 over 3, right? So viewers, the value of this integral is 10 over 3, and this is how we solve this important problem.